Hi everybody. Just wanted to give you a quick update on CremaBot. It's my project where I am web enabling a Jura FX50 coffee machine. Um, as you can see, it's all driven from an Arduino Nano. Looking at the schematic in Eagle now. In short, from the Jura you have two main sets of input buttons that you want to take care of. One is the 6 buttons on the front of the machine for rinse, espresso, cappuccino 1, and again for 2 espressos, 2 cappuccinos, and then the steam button. Also included in that is the display, or the data lines that go to the display, which I'll get to in a moment. Aside from that, you have the rotary encoder, where you can do your various selections to integrate with the coffee machine. So the idea with this solution is to take the 10-pin connector that goes to the 6 buttons and the display, and actually plug those into my own controller, which I can then interface to the Arduino Nano, and then take the outputs of that and send that then back to the coffee machine's default controller board. The idea being that there's no modification required to the coffee machine, no soldering of pins to buttons and that kind of thing. From the coffee machine's perspective, nothing has changed. From my controller board, though, I can monitor when buttons are pressed for some additional functionality, which I'll share later, as well as I can induce a button press from the controller perspective, i.e. from a command on the web app via the USB. And similarly, I can the idea is to also read the data that is sent to the display, read that into the Arduino, and then potentially put that same display onto the web app, so that the actual machine and the web app remain in sync at all times. The display, as we saw in the teardown video, is making use of probably a couple of sets of 74 HE595s, serial in, parallel out ICs, and the idea is, well, that's exactly the same chip that I'm using here to drive the outputs. So we know what the topology looks like, we know what the protocol, how that works. So theoretically, I should be able to read that data. So in this case, it's going to come in. The Jura has a 10-character one-line display. So the assumption is that there's 10 of these 74595s, all connected together in a daisy chain fashion. So the data line is going to push through data bytes, if you could call it that, one for each character, and then it's going to false width modulate between those displays to enable and disable the displays as required to display the actual data on the screen. I'm hoping to actually be able to read that data out in real time, push that through the USB interface to the DLL, and then on via SignalR to the web app, so that you can actually just see on the web app exactly what's happening on the display on the real machine. Okay, so let's quickly go through the various bits. The actual button matrix, as well as the display, will then not plug into the machine's default controller board, but I'll unplug that and plug that into this controller board. These incoming data lines will feed in over there, straight into my Arduino. So you'll see there's column 1, column 2, row 1, row 2, row 3 for the 6 buttons which come in as a 2 by 3 matrix. Those get fed straight into the Arduino. And similarly, well, what I'd then do is I'd drive a serial out through a 74595, and I'd drive again, well, these being optocouplers, so you can effectively look at these as an LED matrix. So again, I've got two columns by 3 rows coming out here, feeding through to the optical transistor on the other side, and again feeding it back out as column 1, column 2, row 1, row 2, row 3. Those getting pushed to there, and there'll be a cable then from my controller board to the coffee machine controller board, which would just then simulate the button presses as it goes. Similarly, the data to the display, or the display lines, are very similar. So what I've done is VCC and ground I loop straight through. So effectively, again, the idea here being that there's no electrical connection between the coffee machine's electronics and my controller board, hence the separation of the optocouplers throughout, and as well as passing the machine's VCC and ground levels straight through. The data in this case is obviously sent the other way around, because it comes from the coffee machine and gets sent to the display line. So the idea here being that these data lines, so D data, D clock, and D load, get fed straight into this side of an LED, or the LED as part of the optocoupler, and straight back out. So effectively, that should not affect the line at all, apart from there's going to be little serial LEDs or diodes sitting flashing in the meantime. So I'm hoping that the little 0.7 or 0.5 volt drop on that line is not going to cause any significant issue with that. So those will be driving these optocouplers, which again feed straight into the Arduino over there, and I can then read the data out. I'm hoping there's no real crazy clock speeds happening there, and I can read it out with the Arduino successfully. Right, similar thing with the rotary encoders. Again, the rotary encoder plugged straight in there, and I feed those straight into the Arduino. And again, by the same 74HE595, I'm feeding those out and back into the machine via these optocouplers. So again, there you can see I'm using VCC from the coffee machine. I'm using that to drive these things out. So again, no electrical connection between this controller and the coffee machine default controller. Additional bits on the controller board are going to be just a 5 volt rail to obviously power the Arduino. The key being that the controller has to keep functioning even though the USB is disconnected, right? So the coffee machine can continue working with or without a PC being present. I'm still hunting for a 5 volt supply inside the machine, hopefully, which should just keep the whole thing running. The fact that we are running an A74HE595 inside the display unit probably means that there's a 5 volt or a close enough to 5 volt supply inside the machine, which I can probably tap off. There's also a 12 volt power or voltage regulator, The idea for this is to drive a stepper driver. So I haven't mentioned the stepper driver before, but the idea here is that I want a stepper driver to be able to move a conveyor system in front of the coffee machine. The idea being, it's easy enough to make the machine make a single cup of coffee, but then you have to jump up and go fetch it, effectively. Where the idea here is to put this into a boardroom situation where you could sit at the table, order 10 cups of coffee, the machine will make them, and once you're done, you can stand up and go get them all, or after the meeting you can get up as a group and go and enjoy your coffee and talk about the what you've just seen. This fantastic automated coffee machine, obviously. Now, as part of the stepper driver, steppers are fairly specific, but you need to home them from time to time. Hence the two opto encoder end stop settings here. So again, these could either take a mechanical switch as an end stop. The idea here is to have two optical encoders or opto interrupters feeding off to home the conveyor each time a cup is exactly placed underneath the nozzle of the coffee machine, and stopping it in time, make a cup of coffee, and advance it by 1 cup each time. So yeah, I've done quite a bit of the actual PCB layout, but then had to move a couple of things around. So as you can see there's quite a bit of lines that I now have to route again. I'll come back to that at a later stage and give you another update. I think in short, that's about it. I'd love to hear from you guys, and if you like this video, please give me a thumbs up, and I'll keep you posted. Cool.